Hello and welcome to this section of the chemistry tutor where we're going to do our final titration problem. I hope up till this point you've gotten a lot of practice and a lot of experience with these titration problems. Never forget, the theme is really always the same. You have an acid, you have a base, they're reacting, and you're trying to find that equivalence point where all of the reaction is basically done and there's no more acid-base, it's all neutralized. You're trying to generally find that sweet spot where that actually happens. So in this problem, you read it, and again, much like the last problem we talked about, it looks like something a little different than what we've done before, but in fact, the core idea is the same. We have a 10 milliliter sample of battery acid. Battery acid, just in case you don't know, is sulfuric acid, which is H2SO4. Now we take this battery acid, this 10 milliliters that we started with, and it's diluted. In other words, we add water to it and bring it up to 100 milliliters with water. After we do that, we take 10 milliliters of this diluted sample, of this diluted acid, and we find out that that little 10 milliliter sample requires 38.7 milliliters of potassium hydroxide, 0.238 molar potassium hydroxide solution in order to titrate it. The question is, what is the molarity of the original battery acid? So again, you've got a little detour here, and it's important to make sure you understand what the problem's actually describing before you try to set off and do anything, otherwise you're just going to get confused. You know, imagine you have a car battery. You open it up, which you should never do, by the way, because battery acid in a car is really caustic. It could really hurt you. But you rip off the top, and there's this really nasty sulfuric acid inside. So what do? You reach in and you grab 10 milliliters of this battery acid, this super concentrated battery acid, all right? You take that into the lab and you add water to it to bring it up to 100 milliliters. Now at this point, you have your battery acid and you add water to it. When you add water to it, you're not changing the amount of sulfuric acid there. All you're doing is watering it down. It's kind of like, we talked about salt. If you have a really salty, chicken soup or something, if you add water to it, you taste less salt, right? You haven't changed the amount of salt there, you just simply added water to dilute it. So we have the super strong acid, we add water to bring it up to the 100 milliliter mark. That's not going to change how much H2SO4 is in there, but it is going to bring up that volume and dilute it. Now once we have that diluted guy, that 100 milliliter, flask or something like that, containing this diluted sample, then we go in and dip out 10 milliliters of that dilution. And we take that 10 milliliters and we bring it into the lab, and then we start adding this base to it, this certain molarity basic solution, and we find out that it takes 38.7 milliliters of this base to titrate it, to fully react with